As we start getting into more complex programs with graphical user interfaces, and especially video games, we may run into situations where we need to work with or write multi-threaded code, which is also known as asynchronous code or parallel code. So before I get into that, which I will do in a later video, let's introduce multithreading so we can understand what it is, why we would use it, how it works, and the new ways of thinking it requires, as well as a new set of problems that come along with it. So what is multithreading? Well, until now, the programs we've written have lived on a single main thread, and you can think of that as the thing that comes in when your main function is called, and then goes through and executes all your steps until the end when there's none left and it exits your program. And notice when we've written our programs, we knew that step A would happen before step B, B before C, C before D, and all the way down to H. And it's important to note that not every task can be multi-threaded, but for demonstration purposes, let's assume our task here can. So let's visualize breaking this task into two smaller tasks and using two threads instead of one to solve our problem. So here, rather than the main thread computing steps all the way from A to H, we have one thread that does steps A to D, and then another thread that does steps E to H. So I have them laid out side by side because each thread executes in parallel or asynchronously. So some of thread 1 will run, and then some of thread 2, and then maybe some of 1, and then maybe some of thread 2 again. So if we focus on one thread, it still works just like we're used to. We know that step A will happen before B, before C, and then before D. And if we focus on this thread, we know E will happen before F, before G, and before H, and they will be executed in the order that they're listed. But when we make a new thread that runs in parallel with another thread, we lose the guarantees of order between the threads. So, for example, if we run it once, the order might be step A, B, and then E, F, C, G, D, H. And if we run it another time, E may happen first, and then A, B, C, and then F, G, H, and then D. Or an extreme case would be we run it and A, B, C, D happens before E even starts, and then E, F, G, H finishes. So this happens because when we make a new thread, we kind of pass that responsibility off to the operating system. So Windows, for example, and Windows will take these two threads and decide on its own which thread to run, when, and how many steps of each thread to run. And we don't really know how it's going to choose to do so. So there's a few different reasons why we would want to multi-thread something. And in this video, let's use the example of a grocery store. So let's say that steps A through H are people waiting in line at the checkout counter at a grocery store. Let's say that each checkout takes about a minute to complete. So doing steps A through H on a single thread, on the main thread, that would be similar to only having one checkout line open. So if that were the case, it would take about 8 minutes for everyone to be completely checked out. But if we introduce another thread or open up another register, one register could handle 4 people and the other could handle the other 4 people. So person A would be being checked out at the same time as person E, and so forth. And we should see an improvement of only taking 4 minutes rather than 8 in order to check everybody out. And if you could imagine opening up 4 registers total, each register would only have 2 people to check out, and that's all happening in parallel. So in theory, it should only take 2 minutes to check everyone out. So for problems that can be parallelized, you should see a pretty big performance gain, because this is essentially what's happening on the processors in our computer. So at a high level, let's say our processor has 2 cores. Each core would be analogous to the checkout lines in the grocery store example. Each core can run a thread, but if we only use the main thread to handle steps A through H, they will all wait in a line to be handled by only one of the cores. By making a new thread, we can utilize both of the cores and have one core handle steps A through D, and the other core handle steps E through H. So that's a high-level introduction to multithreading, and although it can increase performance, it introduces new problems, like I mentioned about how we lose the guarantee of which step will happen when between the 2 threads. In the next video, I'll have a code example that will demonstrate the grocery store example.